I'm going to talk about a brand new concept now, and that concept is called recursion. If you're familiar with computer science, or maybe you've done other programming languages, or even mathematics, maybe you've heard of this word before, but maybe you haven't. So, why am I on Google, I hear you ask? Well, when I started my programming ventures, recursion was something that really confused me. Have you ever seen the movie Inception where the guy goes to sleep and then he's in a dream, but then he goes to sleep in the dream and it kind of plays with your mind and you're kind of wondering, is he dreaming? Which layer of dreaming is he in, or is he awake again? It's very confusing. And the nested dreams in this movie always reminded me of the concept of recursion, and you'll see why. But hopefully in this tutorial I'm going to break it down into simple steps so you'll understand it a lot easier than I once did when I started learning. And I'll show you why. If you Google the term recursion, you get a description here, the process of defining a problem or a solution in terms of a simpler version of itself. For example, you can define an operation, find your way home, as if you are at home. Do you see what I mean here? It's not very clear, is it? And the more you scroll, the more confused you get. It's just one of those things that's you kind of pull your hair out over. And when you look at the images, well, the images don't really help either. You just get this kind of picture over here of something inside something else, and it's just repeating forever. So let me explain to you what recursion is. It helps by looking at recursion in C# in Google, and it gives you a better explanation on what it is in terms of C#. Recursion is a concept in which a method calls itself. And it is exactly that in the world of C#. You define a method, and the method then calls itself. Now, why would a method want to call itself? Well, if you have functionality inside a method to do something, then maybe you want to reuse that code. And why not? Programming is all about reusing code. It saves time, it's easier to maintain, and there's lots of other reasons to do that. So this is what we're going to be looking at today, recursion in C#, and we're going to define a method that calls itself. So we're over here in Visual Studio now. What I want to do is set up a method that calls itself. If you watch any other tutorials on recursion, you'll probably see something where you have to work out the factorial of a number. So 4 factorial is 1 times 2 times 3 times 4. And then you set up a method to do that. I think that's quite a weak and boring example. I think we can use something maybe we can apply in the real world. And I think a search feature is really good for that. So what I want to do, I want to introduce you to my very bad music collection. Here you can see it's quite eclectic. We've got all different genres here. And what I want to do is specify a search term. And that could be anything. It could be a band name. It could be the name of a song. Anything like that. And I want to return all of the music files that match this criteria. So we're going to ask the user for a search term. The user will type it in, and the result will be the full file paths of all of our music files. Now this music collection is very unorganized, hence why we need a search feature. Here I have a music folder here, and inside that I have a folder called Even More Music. In there I have all these new folders, and then I have music dotted everywhere. So I think a search feature might be something good for this example. So the problem, I need something to get the directories inside a file path that I provide the software. So if I provide the software this file path here, I need it to get the directories. The second thing I need to do is to get the software to get all of the files in a directory and check in turn each one of these files to see if they match the search criteria. So it needs to do 2 jobs. And why is this scenario a good example of recursion? How can I apply a recursive method to this example? Well, I want to get the directories and the files for each directory in here. I want to do the same logic in here. I want to get these directories, these files, and then inside these directories, I want to check if there's more directories, then also get the files. So the method's logic pretty much applies to any directory in here. I want to reuse the functionality. I want to use it here initially. Then I want to dig inside these folders, keep digging until there's no more, and then check the files here. So recursion will be a very good example of something we can use for this particular scenario here. So let's have a look how we can do that. So I'm over here in Visual Studio now. What I need to do is create a method, and the method is going to call itself. And the job of the method is to essentially search for a file that the user specifies. So let's set up that now. So the first thing I want to do is ask the user for a search term. So let's do that. Then I want to accept the input from the user. Now I've got the search term from the user, I want to call a method. So let's set up a method that's actually going to do the searching. I'm going to call the method search. I think that's a pretty fitting name. Now I need to define some parameters. What parameters should it take? Well, the first one, we need to know where the music is located on the system. So we need a file path. I think that's a pretty good first parameter. The second one, probably the search term. We need the method to know what we're actually searching for. And the last one, perhaps a reference parameter. And maybe that's a list or an array. And this is going to collect all of our results. So when you search for something, you might have one result, you might have no results, but you also might get 10 results, like 10 matches for your search. So we can't just return a simple type. We need to return something like an array or a list, for example. So I think using a collection such as a list here will be quite fitting. And I'm going to call this results because it's going to contain all of our results that we find from our search. So now we have the path where the music is, we have the search term of what we're searching for, and now we have a collection here that's going to store our results. So one thing you may wonder is, well, why don't we have this as the return value? Why do we need a parameter which is a reference type, like here, for example? Well, the truth is it doesn't really matter. If I set this as the return type, I think it might complicate this example a little more. And what I want to get across to you is how recursion works, where a method calls a method, otherwise known as a recursive method. If I set up a return type, then I have to return the value out of each call to the method within itself, and I think it might complicate the example a little. So I'm going to use a parameter for now, and then when I've actually developed the solution, I'm just going to switch this to a return type so I can show you that example as well. So that's the reasoning behind it here. It's just going to store the results. So when developing recursive methods like this one here, it's always good to get the base functionality first, and that is what it's designed to do. So ignoring recursion completely, that's where the method calls itself, what I want to do is use the path that's given to us and use the search term and see if we can actually get some results from the root folder here. So for now we're going to ignore digging into folders and everything like that. What I want to do is get these files here. So get all of the files for the given directory, and then in turn I want to check each file to make sure it contains our search term. If it does, I want to add it to the result list that we've just created. So let's take a look how we can actually get these files for a directory and then check each title to make sure it contains our search term. So back in Visual Studio now, if we want to work with files, directories, file paths, or anything like that, there is actually a namespace we can use, and this is provided to us. We use the using keyword, and then type in system, and then .io. And IO stands for input output, so it's pretty much anything to do with files, logging to text files, reading from files, all things like that. It's a really useful namespace that we can use. And it's not included by default. For example, when before in a previous tutorial where we used the math static class, and within math we can do various math functions, This is included by default because it's quite a popular library. When you create an application, you may wish to do a lot of things to do with math, for example, and many other things as well. However, not every piece of software you create is going to work with files, so this is why we have to manually explicitly include this library. So that's just a bit of information there. And if you wish to use any other namespace for that matter, you can add them below. So within the system.io namespace here, there's lots of things you can do. You can do all of this stuff here, lots and lots and lots of things. But there are a few static classes you may wish to be made aware of. The first one, for example, is directory. And this is a static class, and using this we can create directories on our system just by giving it a path as a parameter. We can delete directories, we can get files within a directory that we provide. We can do lots of things to do with directories. So this directory static class is really useful. Another one is a static class called file. And with file, we can create files. For example, if we want to create a log file, we can delete files. We can check if files exist. We can move and open files. So lots of different things to do with files. And the last one that's quite useful is the path static class. And path is really useful for working with paths. So if we're giving a file path, we can get the file name from the path. We can maybe get the extension of a file. So we can actually work with a full path, and we can also join paths together. So this is really good for working with directory paths. So there are 3 static classes that you'll find really useful moving forward. And we're going to utilize a couple of these today when we develop our recursive function search here. So I mentioned before that we want our method to get the files in the root directory, just to start with, just to make sure it's actually working. So what we want to do is get all the files in a given directory. And we know this information because this is the path which is passed into our method. So I want to get all the files within this directory here. To do this, we make use of the directory static class, and there's a method called getFiles. GetFiles takes one parameter, and that's the path where the files are located. Now the return from this method is a string array. Now this array will contain the full file paths for every file in this directory. So if we come over to our music now, it's going to get all of these files here, and each item in the array will contain the full file path, so the full path on the system. So that's going to be the return from this method getFiles. So I'm going to store that in a variable called files. So that's going to be all the files in the given directory. Now what I want to do is loop through all of these files here and check that the file name, not necessarily the whole path, we just want to check the file name, to check that the file name contains our search term here. So we need some sort of loop here. I think a for each loop might be sufficient in this case. So Visual Studio has kindly given us some autocomplete help here, so I'll take it. So now in this for loop, I want to check each file in turn and check that the file name of this file contains our search term. So how do I do that? Well, when I want to check, I need a condition. So I know I'm going to need an if statement here. Now, what condition do I need in the if statement? Well, I need to get the file name from this path. I don't want the drive letter, I don't want the folder names, I only want the file name. So when working with path, as I mentioned before, a static class called path is very good for this. And there's a method called getFileName without extension, which will get the file name without, say, .mp3. And there's also one called getFileName. You can choose which one you wish, depending on whether you want users to search for file extensions as well. So I'm just going to use this one. It takes one parameter, and that's the path. And from this highlighted code here, this is going to get the name of the file without the extension. So coming over to our music, it's going to get this highlighted section right here, which is great. That's what we want to check. So back in Visual Studio, now I know that that is the file name without the extension and without the path. I want to try and see if any of that contains our search term. So in a previous tutorial, I covered working with strings, where we did various things with strings, substrings and things like that. And because this is a string here, path.getFilename without extension returns a string, therefore this will represent a string. And when I put dot after here, we have all these different things we can do with strings. And there's a method here called contains. And contains takes one parameter, which is either a character, a string, or actually numerous parameters, a character and a comparison type. But we just want to use this string overload here, and we want to check to see if it contains our search term. So I think that is a pretty good condition. Now there is a bit of a gotcha in here, which I'll reveal a little later, but for now I'm going to leave it. So now we're checking to see if each intern file contains our search term. So that's pretty good. Now, if it does actually contain our search term, then we want to add this path here, which is file, to our results list. So let's do that now. So we use the add method to do that. And we add the file there. If you don't know anything about lists, then I have done a tutorial on that, so I recommend you check that out. So now it looks like we're doing, something pretty good. We're looking at all the files in the given directory, and if it contains the search term, we're adding it to the result list here. And because this is a reference type, it's going to remember what we've added to it when this method has finished executing. That is because it's stored on the heap. It is a reference type. So now what I want to do is actually call this method and provide parameters to it. So let's do that now. So the first parameter I need is the path where the music is located. So let's get that now. Put that back in here. So this is the root directory where all the music is located. The next parameter we've set up is the search term, which we take from the user's input. And the last one, we need to provide a list where we're actually going to store our results. So I'm going to define a local one here to main. So set up a new list here. I haven't given it any capacity because we don't know how many results there are going to be. So I've just created an empty list here. And I'm going to pass this into the method. And when the method has finished executing, we have access to these results down here. And that is because, as I mentioned, it's a reference type. So now what we want to do is just display the results to the user. We could maybe use a for each for this as well. So what I want to do, every time we have a result in results, I'm going to say, let's just output the result. Then maybe I could add like an if statement saying if there's no results, maybe I'll print, the fact there's no results. Okay, so it looks something like this. Now, I appreciate there's more elegant ways of doing pretty much everything in software development, but I try to write this in a way that you'll understand, so it's more easy to take in, because this is just how brains work. So perhaps at the end we can tidy it up. That is optional, but what I want to get across is the principle of recursive methods. So we have some base functionality here, and when developing software, we can test it just to make sure it works. We don't have to completely finish developing the software. So I think now might be a good time to test this, just to make sure it works. So let's run the application now. Now please enter a search term. So let's try searching for ABBA, for example. Why not? So I go in my application, I type ABBA, and it says there's no results for my search. So why is this? Let's try and figure this out. So I go back into the software. So now I'm not getting any results out of it, but clearly I'm adding a result here. So what is going on here? So let's see if we can figure this out. So let's put a breakpoint here and run the software. Type in ABBA. And what do we have here? So it looks like we're getting all of our files here. And are we actually reaching this breakpoint where we're adding the value? So it looks like we're not. So there's something wrong here. We can't seem to get the file name properly, or something quite different is happening here. So it looks like I've accidentally put path here when we should have file. So at the moment we're only searching the file path where the music is located and not actually the file name which is inside the loop. So let's see if that resolves the problem. Okay, so it looks like it's working now. So as you can see, nobody is perfect, mistakes happen, but if you watch my tutorials on debugging and everything like that, you'll know how to fix problems yourself too. So it looks like it's kind of working. So let's try something else real quick. And I did allude to a gotcha earlier. And that is if I search for ABBA where it's lowercase. So I hit enter. It says there's no results. But clearly we have a song called ABBA. So what you can see here is there's a case sensitive issue. That's because ABBA in the MP3 is uppercase, but we're using a lowercase search term. So how do we get around this? Well, file is a string and the search term is a string. So when we use strings, we have lots of things made available to us. And what we can utilize is this method here called toLower. And what that does, it converts all of this to lowercase. And similarly, we can do this on the search term. So now we're comparing all of our search term, all in lowercase, to the name of the file, all in lowercase. So now we shouldn't have case sensitive issues. So if I run the application now and search for ABBA, you can see now I have the result. So now we're ignoring case. So that's pretty good. So I'm going to do one more search and just search for maybe the letter E, just to make sure we get multiple results coming back. So it looks pretty good. It looks like we're getting all the file names that contain the letter E. So that's pretty good. Now I think we're ready for recursion. We have the base functionality working. We're happy it's working for the base directory. Now we can introduce recursion. The problem is when you introduce recursion from the start, especially if you're not proficient, then if you have an error, it could be with just your core functionality. It's really good to get this working before you introduce the recursion to this. It makes things a lot easier. Now let's introduce some recursion into this method. Now I appreciate you may not get this the first time, but don't worry, you will get it eventually. There's a few ways we can tackle this problem. What I want to do, I have this search method that gets the files, which is pretty good. But also I want to give this method the next directory in the current directory here. So for example, we have our music directory. We're already checking the files, but I also want to get all of the directories here as well. And then inside each directory, I want to do the core functionality, which is to get the files, but I still want to get the directories too. And then inside here, I want to do the same thing, get the files, and are there any directories in here? So clearly I need some sort of function to get all of the directories in the current directory. So let's do that now. So I'm going to put that up here. And there is a useful thing we can do to get directories, and that's using the directory static class. And there's a method called getDirectories, and it takes a path. And what path does it take? Well, it takes our root path. And just like before, it returns a string array, and each item in this array will be the full path of the directories in this path here. So I'm going to call that DIRs for directories. And because we know that we want to go inside each directory, we need to kind of loop through this as well. So without even thinking about anything, we know we need directories and we know we need to check each one. So without even worrying about the problem of recursion or inception or whatever you want to say, we know we need this functionality. Now, once we have this functionality in place, we have to work out how to actually deal with this problem. What do we put in here? Do we need anything here? Do we need anything here? Etc. But now we have a bit of a template. So let's have a look at how to approach this problem. I'm giving the root directory to the method. What I might do in this situation is get all of the directories, and with the first directory, I go inside it. Then I call the method again. And what it's going to do is exactly the same thing. It's going to get all of the directories and go in the first one. It's going to get all of the directories, go in the first one. And now we're in the final folder. There's no more directories, so we can't go in the first one. So the last thing we need to do is get the files. So what we're doing here, we're getting the directories, always going in the first one, always going in the first one until we've reached the very end, we get the files. We go out one, go in the next one, get all of the directories, go in the first one, get all of the directories, go in the first one, etc. So that's what we're doing here. We're diving to the very bottom, which is the first thing we're doing. We're going inside, inside, inside until the biggest dead end, which is here, and then we're checking for files. So that's what we're going to replicate in our method now. So the first run of this right here, the search method, we're passing it the path, which is the root directory for our music right here. So what I want to do is get all of the directories, like I just mentioned, in the root folder. And that is all of those here. So that's what this for loop is doing. The first iteration of the for loop will be this directory here. Now we want to actually go inside this directory. So what we can do, we can pass this method to itself. We can call the method from itself even. So what I want to do is call the method. And let's simplify this. So results will never change. We're not defining any new results. We're simply just appending to results when we have a result, when we have a match. We're actually initializing and defining results up here. So every time we pass results around, we just want to simply pass it around. So when we call this method inside itself, we just want to pass this value inside. And the only reason that we want to do that is just to add to it. So we don't really need to do anything special with this here. And the same applies with the search term. We're not changing the search term in here. We're pretty much asking the user for a search term. And as far as we're concerned, it's pretty much read-only inside this method. So again, we're just passing this through as well, just like results. So the only thing that really differs here is the path. So within our first directory, we actually want the directory that we're going inside. So it's going to look something like this. So if I just remove that a little. So this is what it's going to look like. So I don't know if you can wrap your head around this, but the first time this is run, we're getting the directories. We're looping through those directories. So the first directory, we're calling this method again. So now this method is being called with the first directory in the original path. Once it's inside that directory, again we're getting the directories again, until we reach the very end, which is here. So imagine this is the path being passed in now. So now there's no directories. This is going to have a count of 0. So this for each loop isn't even going to run, because if there's no directories in this result, this will be skipped entirely. So now when this is skipped, this method will not call itself, because this is the only time the method calls itself. So what it's then going to do is get all of the files. So it's then getting these files here and checking to see if we have a match, and then the method ends. When the method ends, we go back to the previous call, which is inside this loop. And then it's going to call itself again on the next directory, on the next iteration of the loop. So then it finishes, it goes into the next directory. Here, it checks for directories and files. So does this work? Let's take a look. Why not? So enter a search term. So what I'm going to do, I'm going to give a search term for a file, like this one, for example, hello, hello. Now, hello, hello is located in this folder, inside this folder, and hello, hello is not in the base directory. So by searching for hello, I know for a fact that it's checking quite a lot of folders in order to find this file. So that's a suitable test I could use. So let's run the program. Please enter your search term. Let's type hello in here. So it looks like it's found it, look. So you see this result? It's searching for subdirectories, it's gone inside 2 directories, and it's finally found the file here. So it looks like it's actually working. So this is an example here of a recursive method, and that's just a method that calls itself. And we're just stuffing results into a parameter, which is a reference type, it's a list. So let's do one more test just to make sure it's working. I'm going to take that hello file, which is in here, and paste it in a few more places. I'm going to put it here, I'm going to put it here, and I'm going to put it in here. So now we should get a lot more results. So let's run the program, type in hello, and now you can see I've found all of those instances of that hello MP3. So it looks like it's working. So that's pretty good news. Now the thing when writing recursive methods, you need a way to escape out of the recursion. The recursion will not stop unless you introduce something like a condition, perhaps an if statement, or maybe in our case we have a loop that loops through directories and files. We don't have infinite directories, we don't have infinite files, so eventually this recursive method will stop. However, it's quite easy to have a method call itself endlessly, like in this example. So if I have this method call itself with the same parameters, there's no way for this to exit. So this is the danger of using recursion. So when writing recursive methods, always check to make sure you have a condition or some sort of escape clause. Otherwise your application will crash, freeze, and you'll have a lot of unexpected behavior. So you see if I run the program now, I type in any search term, you can see we have a Stack Overflow. It tried to call itself 24,000 times before it eventually crashed, because the stack is full, the stack area of memory. So always be cautious of this when writing recursive methods. So at the start of the tutorial, I said, oh, we could easily have this collection here as a return. We don't need it as a parameter. So now I've explained recursion, let's kind of modify this code and have this as a return instead. So I set up the return value here. I no longer need to kind of define this up here. So let's remove that part. Let's store the results in the results list here, because this will be our return here. I no longer need to pass this parameter in. And I no longer need this as a parameter. But I need to define a result in here. So let's do that now. Okay. So what I've done here, I've added a return here to search, which is a list of a string. I've defined the new kind of result list of string inside the method here. And now there's a couple of things to note. The first thing I need to do is actually return this out of the method. So I'm going to do that now. And the next thing I need to do, every time I recursively call this same method here, I need to store the return every time I call it recursively as well. Otherwise, we're going to lose this information. So if we're down in the very depths of our folder structure, we've found some files, for example, like here. Well, we need to pass these out of the inner call of the method. Because, for example, I'm not storing a return here. So what I need to do, every time I recursively call this, I need to store the results here. So now you think, okay, it looks like it's working. I've defined the list. Every time I recursively call itself, I'm kind of remembering these values and setting it here. And then every time we have a match, I'm adding it to the list, and I'm eventually returning it out and printing the results. So let's take a look, see what happens. So let's type hello. So it looks like we have a bit of a problem. And this is where debugging is very useful. But I can tell you what is going on here. The problem is we've found some files in the inner depths of our recursive calls. So for example, these files here. Now this is 2 folders deep. So you can see here. Now what is happening is these aren't being remembered, because when this eventually comes out, we're resetting this value every single time we call this recursive method. And that's a bit of a problem. So we're adding the stuff here, but we're also resetting it. So nothing is being remembered essentially. But we are actually adding information in here. If I put a breakpoint, type hello. So there are actually files here. But the problem is it's actually getting reset. So if I look at my locals tab down here, I can monitor the results right here. So I set a breakpoint on return, hit F5, and now you can see I have one result. If I come out of here, and now you can see results is reset to 0 as soon as I come out of here. So nothing is being remembered. So what is going on here? The problem is, well, it's quite a simple problem, but it's very hard to perhaps understand when talking recursively. What we need to actually do is add the results of this search to this list. We can't just replace the list with the results of the search. Otherwise, we're forgetting everything we've learned so far. So what we need to do is add everything from the results of the recursive search. And there's a method called addRange, and what that does, it adds one or more items to our list. And this is the advantage of using a list over something like a simple array. We have these methods available to us. So let's take a look at this now and see if this works any better. So I run the application, I type in hello, and now we have all of our results. They're no longer getting erased through our kind of recursive method calling. So this is why having a return, it adds a little more complexity into things. And that's why I introduced the example with a parameter first, because this isn't getting kind of reset every single time. So when we have a return, yes, we are defining the kind of return here and initializing it to a new area of memory, but we need to remember to add our results from each recursive call every time we call our method recursively. Now, I appreciate this is so much to take in, it's super complicated, but I hope I broke it down in simple terms for you. So if you watch this tutorial maybe 2-3 times, and maybe provide your own examples as well, you'll eventually figure it out, and one day it will just click, I promise you. So this is recursion in C#, and not only C#, recursion is in many programming languages and even mathematics and things like that. So I hope you enjoyed this tutorial, and thank you for watching.